This is an exponential equation which we need to solve. Exponential equations are relatively easy to solve if we can convert the bases to the same thing. Well, if I see this base is 9, this base is 3, if I can somehow rewrite one or both sides so they have the same base, this problem is not terribly difficult. So if I can just think for a moment that 9 is the same as 3 squared. And if we use a property of exponents, when I raise a power to a power, recall we multiply exponents. So this is 3 to the 2x squared equals 3 to the 3x plus 2. We now have an equation where the base is the same on both sides. If 3 to this power is the same as 3 raised to that power, then the two powers, the two exponents, have to be the same. 2x squared must equal 3x plus 2. So what we've done is we've replaced a rather difficult looking problem with a problem that we have a pretty good chance of being able to solve. The standard way to solve quadratic equations such as this is to get all the terms on one side of the equation and set the equation equal to 0. So we have 2x squared minus 3x minus 2 equals 0. And to solve this, we could either use a quadratic formula, which will always work, or we could factor. And in this case, the factoring is not too bad. If we look at the factors 2x and x, those multiply together give me 2x squared. The factors that multiply together give me negative 2. If I look at negative 2 and plus 1, if I multiply this out, I get 2x squared, I get negative 4x, plus x is negative 3x, minus 2. That's a correct factorization. If the product of these two factors is 0, that means that 2x plus 1 must equal 0, or x minus 2 must equal 0. If 2x plus 1 is 0, then 2x must be negative 1, so x must be negative 1/2, or else, if x minus 2 is 0, x must be 2. So we have two solutions to this equation. If we were to take them one at a time and plug them back in, you would find that both solutions work.